Standard deviation is another measure of variability, and our goal for standard deviation is to get the standard or typical distance from the mean. Remember some of the other measures we talked about, the range and interquartile range. So the range gives you an answer of the sort of relatively simple question about spread. So how far away is the highest and the lowest score? But we want to ask maybe a different question. How far away are the scores from the mean? So standard deviation can give us a measure of that. The standard deviation is what we would consider a very reliable measure of variability. It is relatively unaffected by sample size, and it has some of the same properties as the mean. So if you have extreme observations, the outliers can affect the standard deviation. We'll talk more in class about what impacts standard deviation and how we can change standard deviation. So let's think about standard deviation conceptually. What we would like to do when we are obtaining the standard deviation is get the average deviation from the mean. So thinking about getting the sum of the deviations and dividing by the number of total deviations. The problem is that we're always going to get 0 for the sum of the deviations. So in this case, the mean is 70 over 7 or 10. The deviation from the means would be subtracting 10 from each score, so you get a sense of where those numbers come from. And if we were to sum these scores, or the sum of the deviations, we'd get 0. Every time we'd get 0. So getting an average in this way is not going to work for us because we're always going to get 0 for the numerator. Okay, so the sum of the deviations is always going to equal 0. If we have this data set that we're dealing with, we could compute the mean as 10. And remember, our goal is to get the average distance from the mean. So one thing we could consider doing is, instead of having these pluses and minuses, take the absolute value. Why not just subtract 10 from every score, and if it's a negative value, make it a positive value, and then sum all of those and divide by the total number of deviations that you have. In this case, I would get 5.43 if I was using the absolute value. And then I'd interpret that as, on average, the scores are about 5.5 points from the mean. Problem is that absolute values are a really kind of messy way of dealing with data. It's not very mathematically elegant. And so this is a form of standard deviation. It's called a mean absolute deviation, but it's not one that's typically used. In the next video, you'll learn more about computing the standard deviation the correct way, and I want to make sure you know that this is not the correct way. It's just an idea of what we want, and what we want is the average deviation from the mean, and the way we're going to get it is not through absolute value, but through squaring.